Well, thanks everyone for joining us. This is the third in our series of conversations with gold medalists of iStruct. And I'm absolutely delighted to have, I guess, the privilege as well as the opportunity to have a conversation and share insights with some of the most eminent people in the structural engineering profession. One of the reasons that as president of iStruct this year, I had the idea to create these conversations is that in my own career, I've been privileged to get to know people like Albert and to be inspired by them and in many cases mentored. And not everyone has that opportunity. So I wanted to create a space where people could virtually have that opportunity, send in questions and really learn and feel very inspired by those people that have reached the top of our profession. So Albert, I just want to say a huge thank you. It really is a privilege and it's very generous of you. And I hope that, and I'm sure our audience will be as excited as I am to have this conversation and to learn from you. So just want to say thank you to begin with.
No, thank you. Thank you for coming to our small corner of London. And I'm just as privileged to have you here.
Thank you.
You know, we've known each other for a long time, so I'm very proud of your achievements. And I'm also pleased that we're having this conversation.
Thank you. I'll introduce Albert in just a second, but a little bit of insight. Albert and I have known each other for many years. Albert actually supported and sponsored me in my fellowship application for iStruct many years ago. So let me start by introducing Albert. Albert, as you know, is a prominent engineer and design director, co-founding AKT II in the mid-1990s. With over 25 years of leadership at AKT II, he has overseen projects in 50 plus countries and led the practice to win over 400 design awards. Although, Albert, I think earlier you said it might be closer to 500 now, which is just incredible. This even more so, including 4 RIBA Sterling Prizes. Raised in the UK, Nigeria, and Sierra Leone, Albert focuses on integrating design and technology to solve global challenges. Many of you might know that he is actively promoting engineering to young people through AKT II's outreach programs and serves as a trustee for Open City and the African Futures Institute, supporting architectural education and technology in Africa. Albert, welcome.
Thank you. Thank you.
So it's a very, very impressive bio, and there's so much in there. I think in some ways, quite often, particularly when people are at the beginning of their careers, they might hear about all of your achievements and feel like that is completely out of reach, which I don't think is necessarily the case. I think that many young people want to know how to succeed. And for me, understanding how people like you got there is something that is incredibly inspiring. So why don't you start by telling us a little bit about your background in terms of who you are as the engineer before we get into the engineering?
Well, as an engineer, I've been very lucky, privileged, because from a very early age, from a very early teenage age, I was inspired by this engineer in Lagos who was doing a reinforcement drawing, and I thought this guy must be the most cleverest person on the planet. And I thought, yeah, I'd like to be like that. And basically, then the journey to then become a structural engineer became a very tortuous one. But there was a clarity in my mind that this is what I wanted to do.
Because of that inspiration when
That
you were quite young.
inspiration, because for me, in a small studio in Lagos, this guy sitting there with a double elephant drawing board with lines all over it, a reinforcement drawing, knowing exactly where everything is, what they did, and done all the calculation, for me was just mind-blowing. And that was it. And then becoming a structural engineer then had its own challenges. You know, I'm a very old man now. So, went to university in 1978. And when he had university and polytechnics. And so going to university, finding myself as the only black person in the whole department didn't help. And the challenges there actually just strengthened my reserve to be an engineer. And then becoming an engineer, again, that was challenges trying to, but it's fascinating because numbers are numbers. We make assumptions, we do models, and then we analyze them, then we deal with the risks, and then we reanalyze them. We change our approach to the models, we reanalyze them. Subconsciously as engineers, especially structural engineers, you're doing a sensitivity analysis all the time. And what people don't realize is that this actually spills over in terms of how you deal with people, how you deal with architects, how you deal with clients. You're constantly doing that sensitivity analysis with them because you're naturally trained to do that. So for me, having made that decision to be a structural engineer, it's been fascinating using the same process in terms of one's career. And I remember I had a conversation as a very young engineer with Peter Rogers when I first met him. This was when the Sackler Galleries. And I got really depressed one time and I said, oh, so maybe I should do something else. And he said to me, he says, no, Albert, it's better you stick to what you know and do it very, very well than bouncing around. And it stuck in my head. And it still sticks in my head till today. Even though I'm a founding director of AKT, and something you mentioned when you became president about how we create better way of supporting mid-range engineers after they chatted. That is something which resonates with what we do here and the way I think. Because at the end of the day, I've stopped being a design engineer. So even though I'm a founder of AKT, I can actually say that I've probably read 3 contracts and probably done 2 fee letters. What I spend my time doing is designing. And in designing, you're constantly learning. You're constantly challenging. So for me, being an engineer and the person I am is now fused together.
Yeah. I really believe in that, in
Yes.
the celebration of who we are as people,
Yes.
and in that what our values are, what our experiences are, particularly the ones I in my own experience that have challenged us.
Yes.
And once you get through the other side of that, those challenges also become drivers
Very
and the
much so.
motivation behind doing more, learning more, being better.
Yes.
I don't think in that sense I necessarily realized that who I was as a person really manifested in terms of the engineering that I produced or that I produced as part of a team. Yes. But it seems that you also have that same understanding or feeling about who we are.
Yes. My conversation, my father trained as an architect, but he never practiced as an architect because of all the problems of the 50s. But he really valued construction and the industry. So it's not, how do I say it? It's not just pure luck that my other 2 brothers are engineers and we all did science. we all did engineering. It just came naturally, looking at buildings, conversation you have with your parents. So growing up in Sierra Leone and growing up in Nigeria, where you get to understand the issues of post-colonialism and the conversations with one's parents on how, because they trained here. My mom trained as a nurse, my dad trained here. So they understood the whole idea of how you rebuild a nation, what it needed. A lot of infrastructure works. And having this conversation means subliminally, you understand what the industry is about. So he really wanted me to be an architect. My dad really wanted me. Oh God, yeah, he wanted me to be an architect. And I thought he was very disappointed when I took structural engineering. But then he was quite pleased because I work with architects, constantly working with architects. And the challenges is also to help push the boundary of what we can do as engineers. I can remember looking at some of the most amazing buildings, historical buildings. And you think, hang on a moment, you see the structure, we're going to amazing cathedrals, even the pyramid, you think, hang on, somebody must have spent some time to say, that block of stone can carry a certain amount of load. Whoever that person is, that is engineering. Without engineering, architecture for me would be incredibly bland, or almost impossible. So I see the two almost like twins.
Yeah.
You see what I mean?
Yeah, absolutely.
Not
They support
identical
each other.
twins, but they're twins.
Yeah.
They really support each other. So in a way, that's the way one thinks in terms of the profession.
And certainly that's one of my motivations is the beauty of a building that creates a space that is really uplifting and
Yes.
brings joy, but not without depth, that it has that purpose and a function beyond being beautiful.
Absolutely.
That's one of the things that's motivated me throughout my career. And then an understanding of how I can contribute to that, which I'd love to explore a bit more with you. We'll get to some of your projects in a little bit. But to get there in terms of that journey, tell me about, you were talking about always, I guess your upbringing, understanding the need for infrastructure. Tell me about the impact of engineering in terms of how that's influenced you as an engineer. So thinking about the final outcome of a particular building or structure and how that impacts the people that use it and the people around it.
Well, I can split that into two areas. One is the early days. Even before I went to university, I actually did a diploma, and I think my family was worried I was going to be a builder. But you had to understand materials and what they can do, and also understand the impact of how it's made. And I think understanding how things are made and what you use to make things is very important. Because it doesn't matter the shape, the form, the value of a space and everything. If you're going to contribute as an engineer, you need to have an understanding, no matter which hemisphere you're in, how things are done. And all of it is related, but sometimes politics and society tries to pull it apart. And for example, I remember the first project I did. And the very first project I did, I just left school and I was asked to run a site. Seriously, I think I was about 16,
Wow.
17, and I used to get to this site at 5 in the morning to open up this site. And I can remember we were doing a boys' quarters and somebody, that explained about reinforced concrete columns and how you do the shuttering. And I can remember the carpenter came along, built it. And I can remember looking and said, this is not going to hold. And I said, you need to reinforce it. And
But you already had that instinct,
I already had
even
that
without
instinct.
the training.
No training.
Wow.
And I said, it ain't going to work. And he said, young man, you don't know anything. Get out of my face. And I can remember they did it. They started pouring the concrete in, and the whole thing just went, exploded. And I told him to leave the site. And I got absolutely reprimanded for doing that. But my instinct told me I was correct. So there is a first part of that, of actually understanding materials and how things are made. And the second part of that, in terms of how you contribute to space, you need to go through the technical and the educational aspect to actually understand the theory of structures. And people sometimes think, I do believe structural engineering is one of the few professions, and I mean that whatever your training is, you're using pretty much 90% of it when you're working. You may not realize it, but you're using it. You're using the mathematics, you're using it. And then you very quickly understand the value of a space, light, fill, finishes, what a material can do, what a material can't do. You're sent to work overseas, you tend to understand the capabilities. And with those capabilities, you can use that back in your models. Because all we do is do sensitivity analysis to deal with the risk. So you literally put that into your analysis to create that space, to create that light. And I think sometimes the public and even engineers do not realize the value of their knowledge and what they can do with it.
Yeah.
And by actually working closely with the people with a vision, the client, the architect, and understanding their criteria, and then fusing the engineering criteria into it. For me, those are the two parts that allow one to understand the value of what we do as engineering and how it has an impact. And you can even go into, low carbon sustainability and everything on all those issues. But reality is that we are the solvers. We understand the numbers, we understand the beauty, we understand the scale, we understand the making. Once you put yourself through all of those, you understand the mathematics. And now, we now understand the computational, the analysis, the AI, because those tools we use in all of this. So I think it's a fascinating profession. And we need to help to inspire and mentor, for me, that mid-range engineers who've gone through, as you said, you're absolutely correct. They go through, they get chartered, and they're left on their own. No.
For the best part of your career, which is where
yes.
you really start to make
Absolutely,
that contribution, to
yes.
really learn
Yes.
about how to be part of that.
Absolutely. And they miss how you need to sort of inspire them, mentor them, so that they actually understand the bigger, wider issues.
So do you think that it's changed in our profession that, I mean, traditionally, really engineering was almost taught through an apprenticeship type program. So
Yes.
there was formal training, or maybe there wasn't. But a large part of it started with some sort of traditional training.
Yes.
But then that knowledge was handed over through on-the-job training through somebody who mentored you through that process. Do you think that that has changed in the way that we work these days, or do you think that it was a necessary change, or it's something that we need to make sure we still have as part of our lifelong learning, but also in terms of the impact we're able to have?
Well, I think it's a necessary change. It has changed because, when I did the old 4-year engineering degree with a year out in industry, and I spent my year out designing drains.
Really?
Yes, in the council in the middle of nowhere in Wales. But it was an experience. But you then got to split into civil engineering and structural engineering. But back then, 95% of people did civils. Structures were just a small piece. Structures was not well recognized. But structural engineers move leaps and bounds beyond what it used to be. So the on-site mentorship training or apprenticeship training was relevant back then, but it had to change. It was a necessary change because we've now become more, materials have moved. Quality of concrete has developed. We got stronger concrete, not just 25. Even the theory of structures moved from service stress to ultimate limit state, which is very similar to other professions. So we had a lot of catching up to do as a construction industry. And in my view, the mathematics that's leading that is the structural engineers. And in doing so, our understanding and the development of really understand the quality and the properties of materials, new materials, is led by the structural fraternity. So we now work with chemical engineers, manufacturing engineers, and everything. We had to lead that. So we needed to have a much more academic leaning to the training. But to be honest, a lot of the good structural engineering practices have adopted that, not just in the way they bring graduates into the organization, but the way they make sure they train them to compensate for the on-site training. Send them to site, spend some time on site, understand the human interaction of making and the complexity of how you develop structures nowadays. So I think it's a necessary change, and I think that change is still ongoing.
Yes.
I don't think you can change that now.
So how do we ensure, you talked about that kind of the foundation of structural understanding and technology. How do we make sure that that is still something that serves as the basis for young and early career engineers to move forward?
That's a difficult one.
It's a tricky one, isn't it?
It's a very tricky one.
But when we talk about, and I'm going to come to talking about understanding materials and using them in new and different ways,
Yes.
which potentially is risky if we
Yes.
don't have a solid understanding of those basics.
Yes. It's a tricky one because, but it's a necessary process we need to go through.
Yeah.
I think you're quite correct in that way. But I think at the end of the day, as structural engineers, senior structural engineers who've been through, we've had a dinner, we've watched the movie, we've been through the experience. We need to find a way to collaborate. Now, architects collaborate better than engineers. Engineers are too risk averse. And I do believe part of the reason is because reality, society hold us at a higher risk value than they do the architect. At the end of the day, what we do, and architects will not like this, but what we do have a higher value because it has a higher risk value.
Higher impact.
Impact,
if
yes.
things go wrong.
If things go wrong.
Yeah.
And very quickly, we are put right at the forefront when things start going wrong. But whether we like it or not, the whole world, society, industry, technology is going through an evolution, not a revolution, but an evolution. And that evolution is happening much more rapid than we do believe. And we need to be part of that evolution. There are new materials come into place. There are new analytical models and analytical software being developed coming into place, which means we can now do time history. Even though our analytical models at the moment are so crude, incredibly crude, when you think about some of the other industries, we have to catch up. Applying it to structures is way ahead of any kind of regulations we have to work with. And then we're also burdened with the fact that the financial institution, the insurances we need to deal with, deal with the lowest common denominator in terms of codes. And I'll be a bit controversial here. Even the bodies that put the codes together have lost their ability to create sections within the code that allows you to innovate. The old appendices have been diluted, which says, if you can do the research and you can provide the factors, please do it. Now, everybody lose their ability to actually innovate, because if it's not within a certain code, and I mean all the codes internationally, then everybody runs a mile. And it's not helpful for our industry as far as I'm concerned.
So in terms of that innovation, at the beginning when I introduced you, you have something close to 500 awards for projects, which is incredible. You know, in my own career, maybe I've got a couple. Some people would be very happy just to work on one project, you know, to win the one project that might even be in the running for an award. So 500 is something that is kind of, you know, unattainable for many people, but it doesn't happen by accident. A lot of it from the projects that I've seen has come about through that appreciation of design, that incredible knowledge of engineering, but then that appetite for innovation.
Yes.
Tell me a little bit more about that, because I think the idea of innovating and having enough knowledge, one of my colleagues recently called it being courageously competent, which I really like, right? Because you have to be courageous, and not everybody is. But there's no point being courageous if you're not competent.
Yes.
But what comes about from that, and from that mindset of innovation, is incredible projects.
Well, yeah, I think it's fascinating, because my early career is the first practice I worked for that was, you know, was interesting. I can remember I walked into the office and I've just finished a master's, which I didn't realize at the time was probably one of the first masters in structural engineering in the country from Bradford University. I only found out years later. And I walked in and the owner said to me, I don't care whether you've got a master's or not. This is what we're paying you. And at that time, if you want to do any analysis, you had to send your model to Arabs by fax. And they charge you to do every analytical run. Most companies
Why
did
was
not
that?
have,
Because they just...
it did not exist.
That's so interesting.
Stiffness analysis software was only run by Arabs. So they used to charge, and I can remember I got there and I said, what? And I can remember saying to the proprietor, said, no. I said, look here, I'll write a stiffness analysis software. He said, really? So for 3 months, I wrote a stiffness analysis software that allowed us to do continuous beam, simple portals, 2D analysis, which meant we were not sending stuff to Arabs for analysis any longer. And I did all the checks by hand. And I can remember I wrote it on a Commodore PET. And, but while I was at Bradford, and when the first master's program came, the very first of Bradford, I was approached by one of my tutors who was head of the department for the master's. He says, I'd like you to come onto the course. And I said, I've got no money. I owe a lot of money. I've got no money. He said to me, he said, can you look after yourself for a year? I said, well, I think I can manage. I said, right. He said the fees, I can't remember the fees for the course. I think it's about 1,600 or something. I said, I ain't got no money. He said, come in anyway. He said, by the time the university realize you haven't paid your fees, you'll be 6 months into it. And we'll both get dragged in front of the finance committee, and I'll convince them to allow you to finish the course and then pay after before you graduate, which is exactly what happened to the day, exactly 6 months. And then I then graduated a year after I've been working, and I paid off my tuition fees. But, and I do believe because this was one of the first, a lot of the tutors were from industry. Mm-hmm. And it was all about writing understanding writing software using the old cyber computers, which was the size of half this room. Yeah, I think Bradford, Manchester, and Imperial were the only three that had the machines, because Bradford had a nuclear physics department. But we were also involved in assessing the B20 code, which became 5950. And the whole brief we were given was to actually challenge what the industry determined as engineering norms, which then determine the codes. So you came out thinking, asking the constant question, why? 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 And up until today, I still ask why. And I'll give you an example. We're doing a crazy project in Saudi right now where we're using concrete, where we're piling rock to strengthen the rock. And I can remember having a conversation to say, why do we need to put reinforcement in the concrete? No, why do we need the strength of the concrete to be C80, C90? And they said, that's what we need. And I said, why? The way you crush concrete to get the strength, you either use cylinder cube, right? Mm-hmm. And how does it fail? Always in shear across. When you're in rock, where your confinement is 1-to-1, you got full confinement. Why do you need high strength concrete? It's no longer relevant. But the codes and the thing tells you have to do it this way. And I come back to the point. So the training allowed you, and I'm really grateful, the best thing I ever did was that training, allowed you to be innovative, to think, to push, and to make. But that innovation is just not in the engineering, but it's in the process, in creating an environment, which is what this is about, where you're constantly mentoring people, constantly challenging things, constantly getting people to think beyond the normal. So in a way, coming back to the original point, what makes this all happen? Why do you do this? It all comes from the same position. When we say the profession and life works together. And some of those drivers is exactly what you use in terms of the next generation. How do you inspire mid-range engineers? It's all exactly the same thing. We want them to be the future, to deal with what we're dealing with. Climate change is going to need crazy thinking beyond the codes.
Yeah.
How are you going to do that? You need new
And
brains.
beyond what's been done before.
Exactly.
Yeah. But to do it in a way that you have that solid understanding of how things work and a desire to test that and to think about, can it be done in a better way?
In a better way.
Are we doing it the right way to begin with? Just because it's the way we did it on the last project, is it right for this project?
So it's bespoke all the time. And I think also, I do still believe, and I really believe this, I do believe British structural engineers are the best trained structural engineers in the world. I really, really believe that. Regardless of what, I think they're still the best trained. We work with innovative architects, innovative conditions. And I do believe, worldwide, we are well accepted because of the way we're trained. And for me, it's how do you push beyond that? And we do have a situation now where low carbon sustainability is coming into play. We need to understand and codify, and you need people with experience, that mid-range engineers. They're the ones who jump on planes and go to other parts of the world. They need to see what's being done there that survived hundreds and hundreds of years. Just because it's not codified doesn't mean it doesn't work. Their ability as engineers to model those systems and codify it is what we need to do.
Do you mean systems from current and new projects that are being built around the world, or
Absolutely.
our projects or our buildings that have been standing for
Both.
yeah.
Both. If you really think about it, the buildings have been standing for years with no reinforcement in them, working with shear and gravity. That's a method. The analytical models, which we don't know, they're still standing up, that requires massive maintenance. It still works. So how do we then codify and make it work without the high maintenance? But it still works. We may not have a model. And I get so disappointed when I travel, because I do travel a lot, and I go to other parts of the world, and I see structures being done as if it's being built in UK or Europe or America. When you go to other parts of the world and you're thinking, why are you doing this? It does not work with the environment. It may work with Eurocode or British standards, which those nations have no choice but to adopt. But as engineers, we have to think way beyond that if we're going to try and reduce our carbon footprint. We have to take what the locals have been doing, remodel it, and use it. And if that means we get to challenge our own codes. For example, when we did Mazda, some of the stuff we did in Mazda with the first zero carbon city created the conversation on zero carbon. The foundations, we were brought in. I can remember sitting there and the client said, we got interviewed all the engineers for all over the world and said, what are you bringing to the table? And I said to them, why is it that you're putting crushed ice when you concrete in the Middle East? That was my first Middle East project years ago. And they said, because hydration. I said, what causes hydration? Cement. Why don't we take all the cement out? And they said, can you do that? I said, yes. And I can remember we had to import GGBF from India. And we took something like 67% of the cement out. And I can remember the client we actually did a movie of it and spread it all across Abu Dhabi, UAE at the time, to do all the base works was done with very little cement. And we just said, let the sun do what the sun does, all right? Slow the hydration down, take all the cement out, use more binders, which is exactly what we did. That thought process, the amount of pressure we got was off the scale because it did not meet. And I can remember the Estadama was created, the code was Estadama was created using some of our approach at the time. So that is it.
Must have been at least 15 years ago.
Yeah.
So at that time, some of those, ideas would have been very foreign.
It was very foreign.
And not codified.
No.
And to me, we talk about innovation, but actually having that confidence in understanding the behavior of the materials is something that is very inspirational. You're now looking at, in this moment, so you talked about thinking about the conversation around net zero more than 15 years ago.
Yes.
It's very much at the forefront of what we do now. But what's interesting to me is you're still one of the first looking at different ways to engineer, but particularly with materials that are net zero carbon.
Yes.
Tell me a little bit more about that, because, as a designer, I would love to have that courage to be the first. But I have always had a great career where I've collaborated with people that have that depth of knowledge. Not everyone has that opportunity. And so I'd love people to hear a little bit about some of the work that you're doing now and your approach to it.
Well, it is slightly different now. In the early days, it was me banging my head on the wall, nearly getting sacked and dismissed from practices. I remember doing the first glass roof and glass wall on King's Road when I was at Price & Myers, which actually got sent around the country, and my boss, Sam Price, nearly sacked me because it wasn't codified. And he went on holiday for 3 weeks, and I just designed everything, got it tested, everything. And I got into a lot of trouble with that. I remember doing the floating bridge at West India Dockford Bridge, which is tensioned down into the water because it opens. I got into a lot of trouble for that because I just insisted I'm going to do it. And I think when we started this organization, it was an organization where I wanted us to be able to do and challenge engineering and allow people. So the early days, it was me banging my head. Mm-hmm. And yes, I am the main design head of this organization, but it was very clear in my mind that sitting on panels and committees and talking about it wasn't going to work. I had to produce the product. So as soon as we started, it was very clear that some of the projects, some of the which everybody says is not possible, was where you got to go. Don't worry about doing extensions. Don't worry about doing, even if you're doing extensions. I remember the first extension I did, I didn't use any steel work. And everyone said, how the hell are you going to, got to put a steel? I said, no, we're going to do it in timber. And I can remember introducing ply beams. And we say, ooh, ply beams. And I remember I did a job with John Pardy, where they did a stress skin ply to do a canopy that was 12 meters. The trouble I got into. But then creating an organization where you have to create like a Bauhaus, mm-hmm. a space for people to develop the equipment. And if we need an equipment in here to do something, we haven't got it, go out and buy it. Get on with it. Do not stop the engineers doing what they need to do. Have reviews. Push the boundaries. So now, some of the things we're doing now on materials, we're working with Imperial College, Cerotech, in developing, this is some of it, where we're developing materials where the binders we're using absorb so much carbon that by the time you put the cement on it, it's actually absorb more carbon than the original, which makes it
That's so cool.
net zero. And I have pushed it, and I have actually got the team to introduce them to some of my big clients and construction to say, you guys need to get these guys on board with the concrete manufacturers you're going to use on these big projects so that you can put your hands up. But again, you hit resistance on a different level. This is now about economy, about industry, about all of that. But that doesn't mean you shouldn't push it. So there is that side. There's this side that I remember when we got asked, and this is more recent, I've got some amazing brains in my organization. I better not say that too much. Where we did the first island in the Red Sea, where, because it's got corals, we're trying to not to put any liquids in the ground that will seep into the sea. So we came up with a scheme where we'd not pour one piece of concrete or wet concrete. We actually use manual rings and use the sand itself to form the foundation by encapsulating it. That was developing here. And we used timber. We research. I think the first 3 months of the project, we didn't do any analysis. We just presented the client with material research. And we came up with Koya, timber. And the first is now all over the social media was done. Where we're using timber in the Red Sea, where you've got salt, which completely erodes timber. But we're actually using timber. So you got to create an environment that allows innovation to happen. We were talking earlier about the foundations we're doing. We're looking at foundations in rock in a different way. We're going 3-4 times the requirements of bearing in the rock that the local code allows for, because we've done a huge amount of research, the most comprehensive 3D geotechnic I've ever seen. We've done everything we can to make sure we know everything that's going on. We have a research team who we give them free rein to do materials. We're introducing, I was telling about the roof, where we're introducing new materials that are not normally used in our industry into the industry. We're doing some work. I remember doing some work in South Africa, in northern Ghana, where we're using old water bottles to form void formers, to reduce the amount of concrete.
So creative in
Yes.
terms of problem solving.
Yes, to reduce the amount of concrete being used. So we still have the stiffness for a big cantilever roof without putting the old, this is totally outside the code they use. And they normally do stuff like this. Oh, let's get a post-tension expert in, pour more concrete in. No, you don't need that. Literally, they've taken a lot of water bottles, glued the top back on, air, wrap it with a polythene plastic, encapsulate into the concrete. Bingo.
So what's coming to
is
me
the
there
environment.
is innovation, which is a word that is, I think, is used a lot and means different things to different people.
Yes.
But one of the things that's coming to me as you describe a lot of your work and the approach is creativity.
Yes.
Creativity and research. And I think one of the things that I've seen as a common thread in many gold medalists is this desire for research. So thinking differently in creativity, always testing the boundaries, but as well as that being grounded in research and testing, which I think is so important, and maybe something for our audience to kind of take away as complementary to what we do. The other thing that I think is really interesting that you spoke about there is having the environment to work in a way where we can push boundaries as engineers. Tell us a little bit more about that, because you are also a huge advocate for diversity in our profession, which, you know, there are some opportunities to evolve that, but you've been an advocate for many years. So tell us about that and the impact of that in terms of how it's manifested in the work and the creativity at AKT II.
Well, I think it probably started when I was at uni. Because I remember when I started the course, as I said, I looked around and I noticed I was the only black face in the whole department. And I thought, okay, let's get on with it. But I remember we had a class of 72, and there are only 5 women in the whole course. And out of those 5 women, I think there was only 1 from the UK.
Interesting.
The other 4 were from overseas. And I think 3 of them were from Arab countries. I can't remember. I think 1 was from Egypt. And it was fascinating that they kept themselves to themselves. And you start thinking, this is not right. And it was sort of almost institutional. So even the lecturers, when they put groups together to do group work, they put all the group together and they put the women together.
Oh, that's interesting.
All right? They don't mix them. And most of the time, I was on my own anyway. I didn't mind. But very quickly, you realize when you talk to them, they have a completely different perspective to the work that was being done. And those perspectives are so alien. And you start thinking, where the hell is this from? So I can remember when I first got made team leader at Anthony Hunt. It was Tony Hunt, yeah. The first 2 engineers I got in my team were graduates. One was a young lady called Mitsu Edwards. And I still know her till today. I think she works in Paris and she's a fantastic engineer. And another guy was a young guy called Andy Murray, very bright, but completely wacky the way he thinks. They were fantastic. So in a way, diversity for me was, in my mind, is the project that matters. And how do you innovate and get the best for the project if you haven't got a mixed group? So even when we formed this organization, when I decided I've had enough, I'm going to start my own practice. And he said, if you're leaving, I'm coming with you. And then we got Robin. And as I was explaining to you earlier on, we approached Jane and said, why don't you join us? And it was all to do to create an organization that reflects how we thought and what we wanted to create. And I think in this organization, we are totally diverse. We've got people from every part of the world working here. We've got close to, I think it's 40 something, 47 or something women to men. We've got a very high percentage. And we had to think about it positively to make it happen rather than just expecting it will happen. Society needs a bit of a, what do you call it? Boost.
Yeah.
To really understand if you want to innovate, if you want to do something different, if you want to be successful, even financially, you need that diversity. A lot of research has been done.
Yeah.
Even by definition is that the more diverse you are, the more successful you are. So it's not rocket science, really. It's just people's attitude that is wrong. So for us, we embrace it totally as an organization.
And you can see the
We can
results
see
of
the
that.
results of it.
Yeah, which is so powerful.
It's very, and I think for me, in terms of innovation now, it's not just me any longer pushing the boundary. I have a huge organization supporting. And when we do reviews and everything, that's part of the conversation. Where are we on low carbon? Forget low carbon. Where are we on human? The next bit we are dealing with is human sustainability. Because the more we work overseas, the more the human issue of what we do comes into play.
So in that what we do, and just sort of coming to the end of our time together,
Yes.
really fascinated to hear about the journey and the approach to things. Tell us a little bit about some of the projects that you're working on now and how all of those things throughout your career are sort of coming together in some of the work that's happening now.
It's fascinating. I've had a very fascinating career because I've just spent all my time. If you look at my career, I haven't sat in much boards or committees. And I can actually remember the instructor asking me, what panels have I sat on for the institution? And I said, none. And I wasn't negative about it. And I'll be honest with you. Until you became the president, I wasn't much interested. I was surprised to be given the gold medal. And the reason is that I've spent my career just dealing with engineering projects. We've done tons of towers and done probably all the towers that AKT has done, bar one. Challenging the issue of you can actually extend towers without worrying about what's below. You know, where are we? High-low, around here, where we added 13 floors to an existing 17-story building. I remember being lambasted and challenged recently when we did South Bank Tower, when I told the client, don't demolish it. We can add a third more to an existing 30-story tower, and everybody was saying cannot be done. We've done it. And the battle wasn't just with other engineers, the battle was with the local authority. I had to go to a planning meeting because they thought it was an April Fool joke.
You're kidding.
I am not kidding.
Because of the ambition that you bring to projects that perhaps hasn't been seen.
Yes.
Yeah.
And I can remember the developer, a very good friend of mine, and I said, are you sure we can do this? Because everybody was telling him it cannot be done. And I even remember the chairman of MACE calling me into a meeting and going ballistic at me. And we end up in a huge shouting match because he was going to build it to say it's not possible. And I said, he's now a very good friend. So the battle's going beyond that. And the latest projects we're looking at, as I explained to you, we've just finished designing 3 islands in the Red Sea. We're now designing an island. So the whole thought process of engineering and codes and methodology has to be put aside. The real driver here is time and buildability. And then you got to split the buildability into capability that is available in the region. You then need to understand that to a great depth before you worry about the engineering.
Yeah.
You see what I mean?
So also understanding what are the true challenges
The true challenges is,
before you get into the engineering
Yes.
itself.
Yes.
Which brings us back to what you said in the beginning, is that the structural engineer and the skills
yes,
that we have are so transferable to
Very.
so many different parts, and essential that they are transferable.
yes.
So in that, as we wrap up, it's been really inspiring again, as always, to talk to you, and I hope that insight for many of our young and early career engineers, as well as everyone in our profession, resonates with many. One of the things that a lot of younger engineers ask me is, but what can I do right now? In terms of perhaps wanting to be successful, wanting to focus on a particular part of their career. And I find it a challenging question because it's quite broad. But if there's one takeaway for people early in their careers who are aspiring engineers, what would you tell them?
3 things. 1, keep learning. Just because you've got a master's, you're iStroke team member or whatever, no. In reality, you're just starting. Keep learning, be open. I would say that's the first. The second is be generous with your knowledge. I can't even remember who said it. Tell people what you're doing. Explain in a very simple way. Even if they take it and they go away and develop it, it means you've got time to think about something else and develop something. So you need generosity. And I really mean that. You really need generosity, because with generosity, you get the right people around you.
Yeah.
You all support each other. And I'll say, in terms of this evolution we're going through as structural engineers, humanity. Humanity is a big thing which we seem to have forgotten. If you give somebody your word and you say, I'm going to try and do something, try your best. And if you can't, explain it and say, I said I'm going to put this piece of glass here. Oh God, I can't now. But I can get to here, but I have to go through here, 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 here. Don't just say, I can't do this anymore. You need humanity. You need a bit of being humble, and that's going to be essential as we move forward in this evolution we're going on with technology and everything. So I would say those are the 3 things they need. And keep learning, be open, and have a bit of, remember your humanity.
Yeah, I love that.
That would be my take on it.
And in that, my hope is that many people today have learned something and have something to take away from our conversation. And you have been incredibly generous in sharing that with us. So I really appreciate it. I hope everyone watching has found it as interesting as I have. And thank you for joining us.
Thank you.
Thank you.
Thank you very much.